Our final example, solved by using elimination method. All right. So elimination method. It's hard to say. It's easy to do. Hard to say. All right. 2x and 3y, 5y negative. Or sorry, 2x and 3x, 5y negative 4y. Again, I can get rid of x. I can get rid of y. It's your choice. I personally don't like to multiply by negative numbers. The chances of forgetting a sign change is there. So to avoid that situation, if I already have opposite signs, one positive, one negative, that's the one I choose to get rid of every time. So I want to get rid of y. I'm going to multiply both the top and the bottom by some number. I want both those numbers to become what number? 5y and the 4. 20, right? So I can figure out, it's just like finding a common denominator for just two numbers, right? And the numbers are usually pretty small, usually one-digit numbers there, so it's not very difficult to do that. But 20 would be a common denominator for 4 and 5. That's the number we want. You decide what number you want, then you figure out what to multiply by. 5 times 4 makes 20, and 4 times 5 makes 20. That's how you decide what numbers go here. And again, I don't have to worry about multiplying by a negative because the signs are already opposite of one another. So that's already been taken care of for me. If I multiply the 4 times each of the three objects in the top equation, 4 times 2x is 8x. 4 times 5y is positive 20y. 4 times negative 7 is negative 28. You take the bottom equation and multiply everything by 5, all three objects, times 5. 5 times 3x is 15x. 5 times negative 4y is negative 20y. 5 times positive 1 is positive 5. So you get each object multiplied by whatever number it is that's necessary. Again, all you care about is this, that the opposite objects are created. As long as that's done correctly and these change and these change appropriately for changes you made to y, then you're ready just to add the two equations together. 8 and 15 are both positive, so I'm going to get 23x. Positive and negative 20y being opposites cancel. Negative 28 and 5 are opposite signs, so I subtract. And 28 is bigger, so it's negative. If 23x equals negative 23, we divide both sides by 23. We get x equals negative 1. And once we know the value of x, I go back to any equation. I like the top equation the best. 2x plus 5y is equal to negative 7. I'm going to put x right there. Negative 1 goes there. So negative 2 plus 5y is equal to negative 7. Move the 2 over. 5y is equal to negative 5. So y is equal to negative 1. Okay. So, oh, and the correct answer then, negative 1 for x, negative 1 for y. The right answer is in order. What's wrong, Parker?
You did thing, but it didn't equal 3, but both equal the same thing. That's not right.
Sorry. Okay, now one thing real quick. Another part that people sometimes get hung up on is, what equation am I supposed to go back to? I just found this answer, that's all well and good. Where should I go back to get the other answer? If I go back to this one instead, watch this. 3 times x minus 4y is equal to 1. X equals negative 1, right?
Yeah.
That means negative 3 minus 4y equals 1. Move the 3 over, plus 3, we get negative 4y is equal to positive 4. Divide both sides by negative 4, you get y equals negative 1. Same result. It doesn't matter where you go, just do it correctly. Go back somewhere that had both x and y in it. Substitute what you figured out for x or y to find the other answer. All right, don't get hung up on, I think I need to go back to this equation, because he kept on going back to the top equation. That must be the one I have to go back to. Go back to any equation in the problem, and you'll be fine. As long as you get the right answer for the first one, the right answer for the second one should come out.